So I'm putting this video together for the benefit of you that did not have class today because of the disruption to our schedule. So this is going to just bring you through essentially an example of each type of problem that is on today's notes. This is dealing with scientific notation. So the first thing we need to know is that scientific notation is a way of representing really big numbers and really small numbers. By that I mean numbers that have a whole bunch of zeros to the right, like 4,600,000,000, or numbers that have a whole bunch of zeros to the left. And this isn't the worst example of it. And I'm going to say this in the lazy way, 0.00014. So these are examples of really big numbers and really small numbers, okay? So scientific notation was designed to try to shrink these numbers down, to have them take up less space when particularly scientists had to write them out, and also for the fact that when you have operations of really big numbers with other really big numbers, they make even bigger numbers, or really small numbers, say multiplied with other really small numbers, you get even longer, smaller numbers. Okay, so scientific notation is a way of kind of writing these numbers in a type of shorthand. Now, what is really important for us to know is that in scientific notation, to be written correctly, it's going to be made up of two parts, what we call factors. Our first factor is really important we know is going to be written as a value that is at least 1, but less than 10. So if I think of our numbers being n, it can be greater than or equal to 1, but it has to be less than 10. That's really, really key here. And then our second factor is going to be 10 to some power. So it's going to be a power of 10. So all of this should ring somewhat familiar to you, but we'll quickly go through a couple of problems just to make sure that you're on track with these. The other thing is really big numbers are represented with positive exponents for our power of 10, and really small numbers are represented by negative exponents for our power of 10. So let's take one of these problems. The Earth is approximately 4,600,000,000 years old. That's a big number, as we said. So in scientific notation, what we like to do is recognize where the decimal point is, but to write in scientific notation, recognize where the decimal point would need to go. And to make that first factor a number that is at least 1 but less than 10, our decimal point is going to have to get parked right between the 4 and the 6, which gives us 4.6. Now from there, we're going to take that and say we're going to multiply it by 10. And then we just need to know what power of 10 we're going to multiply it by. And that's going to be driven by how many places we would send our decimal point, now that it's between the 4 and the 6, all the way back to where it started. So in this case, the commas make life a little bit easier because I can count by 3s. I'm going to send it back 3, 6, a total of 9 spaces. So this original number, 4,600,000,000, can be rewritten as 4.6 times 10, whoops, not 10 to the 6th, I had already written as 10 to the 9th, times 10 to the 9th. And remember, that's an exponent. I know that looks a little bit big, so we'll clean it up one more time. 4.6 times 10 to the 9th. Okay, so next problem. I have a small number this time. And I'm going to want to park the decimal point, again, in a spot that creates a first factor in my answer of at least 1 but less than 10. So I'm going to park it between the 1 and the 4. So that's going to give me 1.4 times 10. Now this time I'm going to be sending my decimal point back to the left. From there, from where I parked it, I need to go 1, 2, 3, 4 spaces, and because I've gone to the left, it's going to be 1.4 times 10 to the negative 4th. So that's how we will write numbers in scientific notation. Big numbers, a value between that of at least 1 but less than 10 times 10 to a positive power. Small numbers, a value of at least 1 but less than 10 times 10 to a negative power. So I'll ask you to, actually I won't ask you to do anything more because that is converting standard to scientific notation. To work in reverse, we will simply use our exponent to tell us how far to move. So this says move 7 spaces to the right. So my 9.17, when I move my decimal point, I'll go 1, 2, 3, 4, 5, 6, 7. I'm going to fill my spaces, my empty spaces in with zeros. There are 5 empty spaces, so there are 5 zeros. And then I can rewrite my number with the appropriate commas. So 9.17 times 10 to the 7th is 91,700,000. We'll do one more together. This time I'm going to move left 8 spaces because it's a negative exponent. So if I start at 6.287, because it's a negative exponent, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Park my decimal point. You can even put the 0 on the other side, but fill in our empty spaces with zeros. So I'm going to get 0 point, and it looks like 7 zeros. 1, 2, 3, 4, 5, 6, 7, 6, 2, 8, 7. I'll leave it to you to do the last problem on your own so that we can jump ahead to the back. On problems like this, where we multiply numbers that are in scientific notation, we will multiply the first factors together. So I'm going to have to multiply the 9.2 and the 6.8 together. And then we'll simply use our product rules, because we're basically multiplying 10 to the 5th times 10 to the 4th by adding our exponents together. Okay, so let's do the 9.2 times 6.8. Let's see, 8 times 2 is 16, carry the 1. 8 times 9, 72, carry the 1 is 73. Placeholder of 0. 6 times 2, 12, carry the 1. 6 times 9, 54, let's see, plus 1, 55. Add our columns. We have a 6, we have a 5. 12, carry, boom. 62.5, and let's see, 2 decimal places, so 62.56. So I get 62.56 times 10, and because it's 10 to the 5th times 10 to the 4th, it's just going to be, let's see, 4 plus 5, 10 to the 9th. Now notice our answer. This is looking like scientific notation, but it is not completely in scientific notation because our decimal point is not in the proper place. This number is not at least 1, but less than 10. So I need to adjust my decimal point and turn this into 6.256, which means that if I think about where I was in the incorrect spot, going 9 spaces to the right because of my exponent, I just moved 1 space further away. So that's going to become times 10 to the 10th. I move further away from my destination. Okay, so I need to adjust accordingly. So we'll do the same thing with this next problem. I'm going to have to divide these numbers, and then obviously I'm going to subtract my exponents there. So don't get too tripped up by 1.2 over 1.6. 1.2 over 1.6 is nothing more than 12 over 16, which is 3/4, which is actually 0.75. So that's 0.75. times 10. Now careful here, my exponents, I'm doing 4 minus -3. That's going to be times 10 to the 7th. We run into the same problem though. My first factor here is not a number of at least 1 but less than 10. So I'll need to make adjustments. So that's going to become 7.5 times 10. Now think about this. In my incorrect version of scientific notation, I was having to go 7 spaces to the right. I'm moving 1 space to the right, which means I'm moving closer to my destination. So I'm going to have to reduce this exponent by 1 value since I got 1 space closer to where I need to be. So this will become 7.5 times 10 to the 6th. So I talked through all that pretty quickly, but I think you have enough to model these last two problems off of. So for these last two, please make sure you make the adjustments you need to. And one last thing quickly as it relates to the homework, particularly on problems like this. Some of the problems when you divide are not going to be nice, clean answers. So on your homework tonight, on the homework, round, I'll say first factor, that's the first part of your answer, to the thousandths in your final answer, okay? So when you're ready to state your final answer, just take that final factor, particularly when you're dealing with these division problems in homework, round to the nearest thousand times 10 whatever power. So we'll have some approximate answers. So that's everything hopefully you need to know for scientific notation to complete your notes fully and to successfully do your homework. We'll check in again in class.